Hello viewers and learners of the Postgraduate Diploma in Environmental and Occupational Health and Master of Arts in Environmental and Occupational Health. Welcome to this program. Today we will discuss on an important topic, water treatment technologies, which forms an important part of the course MEV 003 and the course is Environmental Law and Management. Now rivers and water. So this forms the lifeline for any country and they support millions of livelihoods of people around the world. But unfortunately, our rivers, our groundwater, all is contaminated with several contaminants. They may be the physical, the chemical, the biological contaminants and thereby causing water pollution. Water pollution is anything but an undesirable characteristic or the degraded quality of the water quality, and that can be indicated by the physical, the chemical and the biological characteristics. So citing one of an example, for example in the southern India we have a city known as Tirupur, and here we have more than 700 odd dyeing units and bleaching units, and this is basically the hub of the textile manufacturing in southern India. And Coimbatore, which is nearby, which is also known as the Manchester of South India. So here we find several of these dyeing units. They can also be the cottage industries, and these dyes which contain organic compounds which are very harmful and toxic chemicals, they are somehow the treatment is not done properly and they end up in the water bodies and the rivers. Several reports even recently, they have published and they confirm that these waters contain higher concentration of certain heavy metals including chromium. So this affects the health of human beings, of the marine organisms, of the environment, and also the topsoil quality is also being degraded and this is lost. Thereby, water treatment is essential. Water treatment forms a very important part, whether it is the domestic sewage or the wastewater or the industrial wastewater that is coming out. Let us discuss the sources that we use for the water consumption. So this comes from the rivers, from the groundwater or from the lakes, and all the sources of pollution in brief. We can come across the domestic pollutants, the industrial setups and also from the agricultural sector. So the contamination of these waters could be due to the heavy metals, certain dyes which are organic dyes, organic compounds, and there can also be the biomedical waste which can enter the system through the hospital waste and the healthcare facilities. So one of the main factors causing the ecosystem's irreparable harm is the industrial wastewater. Let us now see a shocking truth. Groundwater in 12 Indian states, it is found to be contaminated with uranium. Now uranium is a radioactive substance. And nearly 29%, that is 3 in 10 wells that is tested in Punjab is contaminated with this toxic uranium. Uranium in Punjab's groundwater, if you will actually see the reports from the Down to Earth, the Center for Science and Environment, New Delhi, which was reported in December 2023, the count is quite alarming because they say that Punjab's groundwater has 17.7 times more than the safe limit of uranium that is prescribed by the World Health Organization. And the concentration at one such location in Punjab was 532 ppb, whereas the permissible limit should be equal to or less than 30 ppb. So you can see how alarming these quantities are, these levels are. This is the state of our rivers today. Another example or another case study, that chromium and mercury are entering the residences of people in Kanpur. See this slide. The soil, the groundwater and the surface water in Kanpur Nagar, in Kanpur Dehat and Fatehpur, all this was found to contain heavy metals much above the permissible limits. This is again a report from the Down to Earth, from the CSE in December 2024, just 4 months before. Now, the dirty water that comes out of the canals near the Jajmao industrial cluster area in Kanpur, this reaches a specific area, the Chakeri area, and then it directly goes into the paddy fields where agriculture is being practiced. So what happens when these waters enter the agricultural field? No wonder the rice that is being grown there or any other food item and the agricultural product that we get, that will be contaminated with this heavy metal. So the food chain is affected and the biomagnification occurs and the toxic chemicals are being concentrated in the food chain, and human beings, the animals, the animal health, the marine health, and also the plant health, the environmental health, everything is being degraded. At what cost? See the next example, that 81 of India's rivers and their tributaries, they have extremely high concentration of one or more of the heavy metals. What were the heavy metals that were reported and observed? They include arsenic, chromium, cadmium, mercury, copper, lead, iron, and nickel. This is again a report which came in August 2024 in Down to Earth, and the mercury levels that were collected in Delhi in some of the areas for the river Yamuna, that was 9 times higher than the Bureau of Standards, Indian standards, and that the limits cross the permissible limits. So having given you an outline of the present status and the recent reports and publications which have come in the water and the toxicological journals, we have now to understand that treatment of these water bodies, treatment of industrial or domestic wastewater or the any industrial setup, okay, this is highly essential. And now let us see how do we go about treating these toxic waste waters. The effects that all this can have will directly affect the environment, the human health, we have the livestock health which is affected, the marine environment, all are negatively impacted. Reproductive failure, immune system suppression, and acute poisoning also is being reported in some cases. Why? Due to the chemicals that are present in these waters. Therefore, industrial wastewater should be properly treated using physical, chemical and biological methods in order to eliminate its toxicity completely. Now let us see the characteristics of industrial wastewater. So again, if we classify them into the physical, the chemical and the biological, from the physical appearance itself characteristic, you can see the color of the water. For example, if it is a textile dye, you can see whether the color is orange or pink, so that indicates the level of the pollution. Then again the odor, the turbidity, how turbid the waters are. Then the temperature of the effluent and also the total solids that are present in the waters. Then the chemical oxygen demand, total organic carbon, nitrogen, phosphorus, chlorides, sulfates, the acidity and the alkalinity, the pH, trace and the heavy metal estimation forms a very important part in the water chemistry parameters that are being analyzed. And finally, in the biological studies, the toxicological studies are very important. Biological oxygen demand and the oxygen that is required for nitrification and for the microbial populations that are present. All these parameters will reflect the quality of the water. It will reflect the water quality, and thereby you can take steps as to how far and how best you can treat these industrial waters. So how do we define waste treatment? So as we know, waste is something which is a contamination, which is a contaminated water or polluted water body in the case of wastewater. And this treatment procedure, it is a process that removes the impurities from the wastewater and it transforms it into a treatable liquid that may be reused. This can occur within a facility that is designed for treating the wastewater, and that is often referred to as the wastewater treatment plant. If this facility is being conducted for the domestic waste or the sewage water, domestic sewage, then we refer this as the sewage treatment plant or the STP. And the treatment process will encompass the physical, chemical and the biological process for effective elimination of the contaminants. Let us go on with the primary treatment, the first step in the treatment, and this eliminates all the substances that float on the water. So whatever will float is like, for example, oil or the greasy substances, and then later on that could be skimmed away using certain tools and the equipments. Then we have the settleable solids, that is certain solid material which can settle to the bottom of the tank or bottom of that equipment what you are using, and then that could be taken out using certain tools. So the primary treatment itself, it will remove the larger particles. For example, it could be the pieces of wood or the leaves or the twigs, some plastic material, and all this can remove at least around 30 to 40% of the suspended matter and also the BOD. Now, in the primary treatment process, we have several steps. For example, the first step is the screening. Then we can use communitors where you can even grind or reduce the particles to smaller size for convenient removal. Then we have the grit removal and the sedimentation process. So in the primary treatment, let us first understand what the screening mechanism is. So in this figure, you can see that scores or the fine or the medium screens are being used, and here the rough particles or the suspended matter, they can be eliminated using these screens. The coarse screens would be equal to or less than 50 millimeters, medium between 25 to 50 millimeter, and the fine screen that will be around 10 to 25 millimeters. So as I said before, the large or the coarse particles like the paper or the plastic, then leaves, all that visible to the naked eye. So all those can easily be removed using this process, and this is the first step to the treatment procedure. The next is the grit removal. This is often done in the grit chambers. Here in this you can see that these grit chambers are elongated and narrow reservoirs, and they are specifically engineered in order to slow down the velocity or decelerate the velocity of the fluid which is entering, and that way it will facilitate the sedimentation of the solid particles from the water. And then when these particles have settled into the water in that tank, then that could be removed using certain equipments and certain tools. So this is the second step. After the screening, we do the grit removal process. After this, there are certain primary clarifier. So then the wastewater then moves on to these tanks, and here they are allowed to remain in the tank. There is a detention time for about 1 to 2 hours, and then here we allow them for gravity settling. So again, the particles which are not filtered out completely, again by the effect of gravity, they can still settle down and then they can be removed. The solid particles that have settled, that could be taken out as the sludge which settles to the bottom, and that could be scraped with the help of certain mechanical scrubbers or scrapers, and then that sludge can be extracted for the disposal. In this primary clarifier itself, we have the flow equalization. This is nothing but it will address certain operational issues. For example, the quantity of the flow, that effluent which is entering into the tank. So the fluctuations in the flow rate and all this, it could be enhancing the efficiency of the treatment process in total. Then we have the sedimentation tank. So as the name suggests, the sedimentation occurs and it will eliminate the settleable organic material and also the floating debris, and this can effectively eliminate 50 to 70% of the suspended solids and 25 to 40% of the biological oxygen demand. So here in this first step in the primary treatment process itself, you have seen how many sub-steps and procedures there are, and this can easily eliminate 40 percent of the floating material, of the dissolved suspended solids, and also some amount 35 to 40% of the biological oxygen demand also can be removed with careful processes which are done. The next step is the secondary treatment, which uses the biological organisms for the efficient removal. In the secondary treatment, 85% of the BOD will be removed, and this involves the introduction of live microorganisms and biomass, which can eliminate the waste through their metabolic activities. Now, this will encompass the aerobic, the anaerobic treatment, and also the anoxic treatment, which can efficiently eliminate the pollutants from the wastewater. Now, under the aerobic system, we have two different subcategories, that is the fixed film systems, and the name indicates fixed film. So here that means the whatever system we are using there is fixed, and the microorganisms will be attached to coarse material. It could be certain rocks that are there in the tank, or some plastic material which is then seeded with the microorganism, and then when water flows over it, then the microorganism through their metabolic activities can convert the organic compounds into the simpler ones, and thereby the waste can be effectively treated, and the toxic waste can be eliminated. In this, the first one is the trickling filter. So this looks just like a sand filter, and there is a tank, and it is a fixed bed bioreactor. This will eliminate the coarse particles. There is suspended organic and inorganic waste and small colloids of the primary effluent. All this can be successfully removed. And here, as I said, there inside the tank there are some coarse stones and pebbles which are kept, and on that there are the microorganisms can be seeded, and when the wastewater is poured from the top of that tank, then that trickles down slowly, and then that will interact with this fixed bed bioreactor, which has the microbes which are seeded into it, and then the waste can be degraded, and then the sludge can be collected, and then it can go on to the next step for the clarification. In the same way, there are rotating biological contactors. Here a high degree of organic removal and nitrification can be carried out. Now in this rotating biological contactor, you can see that this has series of disc which is attached to a shaft and a motor, and this rotates at right angles to the water which is entering into the wastewater which is entering into the system. So thereby there is also continuous aeration, there is oxygen entering into it, there is aeration, and due to this the microorganisms are seeded onto these shafts and the systems, and then they can eliminate and degrade the pollutants effectively. Then in the aerobic system, so this was about the fixed film. The next in the aerobic is the suspended film systems. So here the first one is the activated sludge system. So there we find, in the previous slides we have seen that the microorganisms were fixed to some part of the bioreactor. But here in the system itself, in the liquid itself, the microorganisms are introduced. There is a stirring tank, and the air is continuously entering the tank, and the microorganisms which are seeded into this system, they will be continuously rotating with the help of the stirrer, and these microbes can then degrade the organic matter in the wastewater. And the activated sludge consists of the live bacteria and also dead biomass, and the sludge is also collected after the effective elimination of these toxic waste. The clear liquid, again it is collected and it goes on to the next part of the treatment procedure, and the sludge which is also referred to as the activated sludge, a part of it which is settling to the bottom, which contains these bacteria which are effective in removing the waste, that is recirculated back into the aeration tank or the first chamber, the first tank, and this is also referred to as the recirculation of the activated sludge procedure. So this is a very good procedure for eliminating 80% of the organic waste. The next in line with this is the oxidation ditch. So this is a system here you see in the figure, and they are large scale projects or large scale extended form of the aeration systems which are used to remove the organic matter, the nitrogen and the phosphorus. And here there is a rotor which is mechanically operated, and again there is agitation, there is entry of the air and the oxygen, and it is basically a modified activated sludge process, and they have long solid retention time, and proper efficient biological treatment will be possible in such tanks. The next is the lagoons. So lagoons are nothing. In this figure you can see that they are large man-made ponds, and they are designed to treat the wastewater through the natural process, also through certain biological processes. And the bacteria, for example here chlorella, then the cyanophyceae, certain algae are being used, and it is cost effective, it is energy efficient alternative compared to the other procedures, because here there is no big equipment which has to be employed, but it is totally dependent on the sunlight, on the natural microorganisms, and long retention periods, like for months these the solids can be allowed to interact and mix with the natural daylight, and that way photocatalysis and other processes occur, and that can definitely help in cost effective and energy efficient treatment of these toxic contaminants which are entering the water bodies. The next is the anaerobic procedures. In this comes the upflow anaerobic sludge blanket, or the USAB, which is referred to in the short form. So this is an anaerobic digestion process. So there is the wastewater which is entering the reactor as shown in this figure, and the water enters from the bottom of the equipment and it flows upward. So that is why in the title we can see the name refers to as upflow. So the wastewater is going upwards through a blanket of granular sludge. And this anaerobic microorganisms, they break down the organic pollutants, and the first step in this is the acidogenesis, where the acidogenic bacteria thrive, and there is an acidogenic environment which is created in that tank. After that, acetogenesis occurs, where acetate is produced, and after the acetogenesis, then the methanogenesis occurs, where methane and other byproducts are released, and the methanogenic bacteria triumph over there, and then the biogas is produced. So this biogas can also be used for other processes, and this is highly efficient in removing the pollutants, and it is generally used very well efficiently for the industrial wastewater and also for the municipal wastewater treatment. Finally, after the primary treatment and after the secondary treatment, we come on to the final stage of the treatment, and that is the tertiary treatment procedure. So once all the BOD and some of the physical and all the chemicals have been removed, there is another step which involves the disinfection of the water, so that the water can be recycled and reused effectively. So this tertiary treatment will see to it that the parasites, the microorganisms, the inorganic chemicals, all these are completely eliminated from the system. So that employs the adsorption, the membranes or the membrane filtration and techniques, nanofiltration, enhanced filtration, ion exchange, and reverse osmosis procedures, which are highly effective for the tertiary treatment processes. The first step is disinfection. Now, always you would have seen, even at home, when the water supply is being given to your home, sometimes you have a feeling that the water is chlorinated. So chlorine is a bleaching agent. Chlorine is highly effective in removing germs and microorganisms, and so chlorine addition to the final effluent does help in the disinfection, and it is a crucial step in the wastewater treatment. So from decades, for a very long time, disinfection was happening through the chlorination of the water bodies. Later on, we extended this to the membrane filtration, the UV rays, ultraviolet rays, ultrasonification and nanofiltration, and ozone and the ozonification, ozonation, which are highly effective for the disinfection. Then we came up with the procedures and technology, the carbon adsorption technology, where the organic compounds are removed using the carbon adsorption, where activated carbon powder is being used, and when the water falls over it, then also through the adsorption, many of the contaminants can be effectively removed. Then recently, phytoremediation by the use of certain plant species like Centella asiatica, Ipomia aquatica. These are also able to help remediate bioremediation in the heavy metals and the water pollutants from the soil. This could be effectively done using the phytoremediation techniques. Finally, effluent polishing is also a step which is being used for the treatment procedures, and this is very useful for removing the suspended particles, the biological oxygen demand from the secondary effluent. Here, the granular media filters are used, and effluent polishing is also a fine technique for the treatment procedures. My dear students and learners, today we have discussed the water treatment technologies, and we discussed the primary treatment, the secondary treatment, and the tertiary treatment technologies that are available to treat and to disinfect the industrial wastewaters primarily. We also discussed them in the introduction with the help of the state of India's rivers and how they are polluted with toxic heavy metals. Therefore, treating of these industrial waters is very important. It is highly essential, mandatory, and the laws and the policies have to be fixed and thereby to achieve 100% success rates in the same. I hope you have had a good understanding of this course of this topic in MEV 003. Thank you for your patient listening.